STAAR Review, page 31, transformations of linear functions. Okay, so we did the notes on the last video. Quick review. Looking at y equals mx plus b, we have two values that are changing the way our line looks. We have the slope, the m number, and the y-intercept, or the b number. The slope, if it gets bigger, the line is going to get steeper. If the m number gets smaller, the line's going to get less steep or flatter. All right? That's all the slope does. However, if you do put a negative sign on the slope, it doesn't change the steepness. Like say I have a slope of, 4. Say it's this steep. If I make that a negative 4, it's the same steepness, but now it's negative going downhill the other direction. All right? So that's what happens with m. With b, the larger b gets, the more the line moves up. The smaller b gets, the more the line moves down. So if I have b is 8, it's gone up 8 from just b being 0. Let's take a look at some examples on this page. So we're comparing everything to the parent function. Remember, it's y equals x. But more specifically, you can think of it as having a slope of 1, y equals 1x, and a b value of 0. So this is like y equals 1x plus 0. It's just the basic line that goes through the origin. Okay? So what is different about g of x here? Instead of a default slope of 1, we now have a default slope of a 1/4. How is that going to change the line? It's going to make the line go like that. Okay? So you could say it gets flatter, or you could say it gets less steep. Okay? Now, getting more specific into things we learned with parabolas. If the number is not in parentheses, it's a vertical change. Okay? If it is in parentheses, it's a horizontal change. This 1/4 is not in parentheses, so we consider that a vertical change, not in parentheses. So that 1/4, what's making it less steep? A vertical compression. You could think of it as squeezing it vertically like this to force it to be less steep. Okay, you're squeezing it vertically. All right, number 2, we have our parent function again, but this time in our g of x equation, it's g of x equals 2x. So the opposite happens. The m number's getting bigger. So it's going to do this. Okay, and you can graph this in the calculator, and you can graph each of these just like I did on the last video, and you'll see it be steeper. Okay, so it's going to be steeper. Okay, it's still not in parentheses, so it's a vertical change. We're going to call that a vertical stretch. Okay? When you're dealing with lines, the most important thing is to understand steeper or less steep. I know this is a little bit challenging. This is easier with parabolas, which we'll get to later in the book. Let's move down to number 6. Y equals x again is our default, but now our g of x equation is y equals x. Oh, g of x is equal to f of x plus 4. Okay, so what is that doing? We have a new, if f of x is equal to x, so you could basically substitute in the x right here. So the new equation is x plus 4. We're not changing the slope. There's no number in front of x. But what are we doing? We're adding 4 to the end. So we have a b number being added on. Remember, the b number makes it move up or down. Translation. And that one is going to move up. So number 6, we have a vertical translation. Specifically, it's going up 4. Okay, once again, when it's not in parentheses, it's always a vertical change. Okay, number 7, we have our parent function again, but now we are throwing a 2 in front of it. So g of x is the same thing as the f of x line, but now we're throwing a 2. Remember, f of x is the same thing as x, so it's like saying y equals 2x. We have a 2 in front of there. So once again, that 2 in front is making it steeper, okay? And once again, we would call that a vertical stretch. Okay, and that is page 31.